Now, load bank types and comparison. So what types of load banks? Resistive load banks function pure kilowatt loading using heating elements. See, generally these types of loads are used, okay, when you have a budget constraint. Okay, power factor unity 1. Okay, advantages: simple operation, lower cost, immediate full load capability. Easily you can put the full load. Now, what are the limitations? Cannot test reactive power handling, limited real world simulation. It is not possible to put the reactive load because it's a unity power load, resistive load. So this is the limitation. If you have a reactive load, in that case, we should perform this test, not this. Okay, advise your clients like that. Okay. Applications: basic compliance testing, engine brakes in, carbon burn off. So these are the important things. What is basic compliance testing? As per the NFPA and other authorities, this is okay. They are okay if you carry out these tests. So you are complied if you have done these tests. Then carbon burn off is possible because it is putting on 100% load. Now, reactive load banks. What are the reactive load bank function? KVR loading using inductors and capacitors. Inductors and capacitors are used. Resistive loads are not there in these banks. It's only inductive banks. You can simulate purely motor loads. Whenever you have pure inductive or capacitive load, then these banks are important or used. See, power factor is lagging 0.8 typical, which is designed for diesel generator. Limitations: more complex controls, very complex, okay, and higher initial costs. And what are the applications? Motor load simulation and voltage regulation tests. During this inductive loads, voltage fluctuation happens because of, we have seen, capacitive load and inductive load, how the energy transfer each half cycle is happening between capacitor and inductor. So during that, voltage regulation testing is very much important. Now, we have a third type of resistive or reactive bank. Combined kilowatt and KVR loading capability. These both things are combined in this bank. Variable, what power factor is variable from 0.8 to 1. As you switch on the resistive load, power factor will be 1. Inductive load or capacitive load, it will degrade. Okay. Advantages: complete system testing, real load simulation, maximum flexibility. See, everywhere you cannot have the pure resistive load. The loads have different characteristics. All three loads are there on each DG set. So this capacitor or this, what you call it, load bank is very much important because it will test every scenario. All types of load will be tested. What are the limitations? Highest cost, complex operation requirement. Operation is complex because you need to adjust the loads. Okay. Cost is also higher because all three loads will be there. Resistive loads are cheaper, heating elements. Simple. Application: comprehensive testing and commissioning. Whenever you are setting up a new DG set, then this testing I will advise. Resistive reactive banks, because it will simulate all the load scenarios. So keep in mind, whenever you are installing new DG sets, then this system is required, this load testing. Then power quality analysis can be done in this. See, if you are a professional, and then you can convince your client, if you should buy this bank, not this. Okay. If you bought this bank, then it will be advantageous than your competition because you have the real simulation, real load simulation. You can convince your client that this is the advantage of this particular load bank and you have a added advantage. Okay. So real life scenario simulation can be done because of this bank. So this is important. Now, basic load bank sizing formula. It is very simple. I'm telling you, required load bank capacity is equal to generator rating in kilowatt multiply by test percentage. All the time we test it at 100%. Okay, and you should have the bank which is 100% of the load DG set. See, generators are of different capacities and your bank is big. You cannot put entire load, more than 100% load on the DG set. That is why this formula, generator kilowatt multiply by test percentage. That calculation you should have 25%, then multiply to kilowatt. That much load bank should be switched on in first step, 25%, then 50%, 70%. So you should have this test percent and calculation handy during load bank testing, because each generator set has different capacities. Okay, accordingly the percentage will vary and the number of banks you are switching it on is different for each generator. So this calculation is very much important. Worked example, 500 kilowatt generator, 500 multiply by 1 because it is a 100% load. For 75% multiply by 0.75, 375. So this way you need to do the calculation and keep it handy. Now, what is the sizing note? Always size load banks 10 to 15% above calculated requirements to ensure adequate capacity and accommodate generator overrating. See, generators are overrated sometimes. So to accommodate that, you should have at least 10 to 15% more capacity load bank. Otherwise, you need to bring the smaller bank afterwards because it will not suffice the DG load. So better to have 10 to 15% more capacity bank than the DG, than this 500 kilowatt. So you should have 510 or 515 kilowatt bank. Now, key consideration, what are considerations? Generator nameplate rating versus site rating. That you need to consider. What is the site rating and generator nameplate? Then altitude, temperature and derating factors. What are these derating factors? We will see. Okay, on the altitudes, the capacity of generator goes down. Okay, then at the temperatures, less temperatures also it comes down. So that we will see. So altitude and temperature derating factors we should consider. Power factor requirements, that also we need to consider. If particular client has a power factor requirement, then future testing needs. What are the testings required in the future for this particular DG sets? Those also you need to consider while selecting the bank. Okay,